Hello everyone, and today we're going to learn about the chain rule, and the biggest challenge of the chain rule is identifying cases whereby the chain rule will have to be applied. So let me give you an example whereby the chain rule will have to be applied in this case. So if a function f of x was equal to sine 3x squared, in this case the chain rule will be used. The chain rule is used in cases whereby the function given to you could possibly be a composite function. In this case, u of x could be 3x squared and v of x could be sine of x. Hence this function over here would be, f of x would be equal to v u of x. That's a composite function over there. v u of x is a composite function that's equal to f of x, and this is a case whereby you'll have to use the chain rule. To get a little bit more practice, I'm going to give you practice questions to identify composite functions and where to use the chain rule. Here are a number of functions where I would like you to pause the video and attempt to determine in which cases should the chain rule be used. In other words, determine which of these functions could be a composite function. Pause the video and give it a shot before we solve them together. So, for the case of cos of x is a function, but it's not a composite function. We will not have to use the chain rule. Cos 2 of x could be a composite function. E to the power of x could not be a composite function. E to the power of x is not a composite function. E to the power of 3x is a composite function. X squared is not a composite function, but x plus 1 squared is a composite function. And for those composite functions, let's see if we can determine the two functions that make up these composite functions. In other words, the u of x and the v of x. In this case, the u of x could be equal to 2x, and the v of x could be equal to cos. The v of x could be equal to cos x, and vu of x should be equal to cos 2x. In this case, u of x could be equal to 3x, while v of x could be equal to e to the power of x, and u of x would give you e to the power of x. And for the last one, u of x could be equal to x plus 1, while vx could be equal to x squared, and vu of x would give you x plus 1 squared. Okay, let's move on. Okay, first, f of x is equal to sine 3 of x squared, and we've already established that sine 3x of squared is a composite function. So first, we'll identify u and v. So u will be equal to 3x squared, while our function here, y, since f of x is equal to y, will be equal to sine 3x squared. So if u is 3x squared, we can safely say that y is equal to sine u, because u is equal to 3x squared. All I've done is substituted this value over here. All I've done is substituted u into this equation. And now to find the derivative, du dx will be equal to 6, while 6x, while dy du will be equal to cos u. The standard derivative of sine u is cos u, and to find the derivative of u, I use the power rule. Hence, now we can see that we found du dx and dy du. So du dx multiplied by dy du, as we can see, du and du cancels out. This would give us dy dx, which is what we're looking for from the beginning. So now we have established that you have to multiply these two derivatives. So we'll have to multiply du dx, which is 6x, multiplied by dy du, which is cos u, this will give us 6x cos u, but we know that u is equal to 3x squared, so we must substitute u back into the final answer. So 6x cos of u, which is now 3x squared, will be 3x squared. Hence, dy dx will be equal to 6x cos 3x squared. In other words, f prime of x will be equal to 6x cos of 3x squared.